STMicro, and I believe you'll be telling us about laser beam scanning light engines. Um,
Perfect. Well, so let me start screen share. Thank you for having me. I appreciate it. And I'm the last talk of the day, so hopefully, people find people find it interesting. So thank you again. I appreciate being here, and thank you for audience for listening as well. So yes, you're correct. Today I'll talk about the LBS technology, and I'm going to talk about a broad spectrum of challenges and opportunities and benefits around the entire architecture of LBS-based systems. So this is the agenda today. I'll first talk about the principles behind the benefits of LBS for those of you who are not familiar, and then get into a little more detail on the optical light engine designs for these kind of devices, and then talk about the different architectures that you can get by using laser beam scan technologies. And then we'll delve into combiner optics because at the end you need to have a whole overall system. So it's not just having a micro mirrors or even a light engine, but the entire optical stack is really important to talk about combiner optics, and that'll lead to a discussion about diffractive waveguides, which seem to be all the rage right now. And we talk about how LBS and the diffractive waveguides work together. Briefly talk about the laser alliance, what we're trying to achieve, and summarize and take questions. Okay, very quickly though. So, I think we all know this. If you look at the challenges and the opportunities for AR wearables, there's really a tale of two devices. There's the one sort of all-day wearable device that everyone talks about, everyone wants as the holy grail, which means that you have to have something very small and lightweight, of course. It has to work all day long, and then it has to work inside and outside. It has to have, pleasing aesthetics and so on and so forth. On the other side of the equation, you have a much more immersive application where there you demand very high resolution, very high field of view. We need to have very focus and a range of other performance attributes. So really, you've got what I'll call a practical and useful device in the case of smart glasses, and then you have much more immersive and I'll call somewhat niche today, such as the HoloLens, such as a Magic Leap type of devices. The good thing is, we believe, and I think you'll see that LBS technology can address both of these for a display perspective. But I also talk about the fact that you need more than display in order to deliver this vision of products and devices, and that'll touch upon a little bit later in this presentation. So getting right into it, again, if you're not familiar with it, I'll talk very briefly about the principles and the benefits, principles behind and the benefits of laser beam scanning. So how LBS works is quite simple, as shown as animation. You have basically three lasers, R, G, and B. They go through collimating lenses to collimate the light. The light goes through beam combining optics to have a singular beam. The beams get scanned back and forth in a raster scan pattern to display the image either on a screen, if using a projection mode, for example, or through some combiner optics to your eye. And that's really the fundamentals of how LBS works. It's pretty straightforward concept. And really the benefits of LBS and why a lot of companies are choosing to really pursue this approach for near eye display is really several fold. One, of course, is very high brightness. You do get millions of nits coming out of lasers. That's why people like to use lasers and laser sources for this. But more importantly, you can have high brightness at low power. That's really critical. That's really due to the fact that when the laser when the pixels when an image is low brightness or turned off, the lasers turned down in power or turned off in some cases. The other thing you'll see a little later is much smaller form factor, so it enables you to embed these in a pair of fashion forward glasses. Um, it's also the other key thing is it's scalable both in terms of the field of view and the resolution using the same underlying architecture. In other words, if you have a certain particular mirror design, then around the boundaries of that design, you can scale the field of view and or resolution without having to redesign the entire device, which I think is a very powerful attribute as well for LBS. So let's talk about what that means as a light engine design and how that unfolds. So on your screen here on the left-hand side is the optical light engine that was designed many years ago, really for pico projection. And in those days, the lasers were discrete or not packaged, I should say, and they were typically, TO can lasers they call, typically around, they're fairly large. for very, very large size